Assalamu alaikum students. This is a continuation of the previous lecture. That was the even elimination reactions. In that lecture we have studied the introduction to the even elimination reaction and the mechanism of the even elimination reaction. In this part we will be studying the conditions which favor the even elimination reactions and the orientation of the product of the even elimination reaction. So now to continue the orientation and the possibility of different products and the conditions which favor the even elimination reaction. These are some examples of the even reaction. Here, these are the compounds which will undergo only even elimination reactions. That is, the tertiary halide, the formation of a tertiary carbocation, and we will get an even elimination. Allyl halide, and we will get an allyl carbocation and an even reaction. Similarly, benzylic halides, that will produce a benzylic carbocation, and the resultant product will be an even product. Alpha heterosubstituted halides, these, it is an heterosubstituted. Here we have oxygen, and also the result will be an even reaction. Now the secondary halides. The secondary halides may undergo even reaction and may undergo E2 reaction depending upon the conditions. Here if you see the secondary carbocation, which is less stable, and the possibility is that it may undergo even reaction or may undergo E2 reaction. Okay, the primary halides, that are the substrate that will never undergo even reaction. The primary halides, because the primary carbocation are the less stable and doesn't exist independently, so the formation, when the formation of carbocation is least possible, so the even reaction will never occur in the primary carbocation or in the primary halides. So we can summarize now here that even mechanism is the loss of leaving group, and the first step, and the second step is the deprotonation. First, the leaving group loses the substrate and a carbocation is formed, and then a double bond is formed between two carbons. The same is the case here. The first is the slow step, formation of carbocation, and then the base attacks the proton or the hydrogen and removes the proton, and we get a double bond or an alkene in the substrate, in the as a result in the product. Elimination reaction mechanisms. E1 mechanism, it is similar to SN1. It is an unimolecular process. It has the carbocation intermediate. It is typical of tertiary substituted alkyl halides. Carbocation, and we have a double bond. Now the effect of different conditions on the E1 reaction. The first one is the effect of solvent. The solvent has very much important and basic role in the E1 reaction. That solvents will favor the E1 reaction, which can dissolve and stabilize the carbocation. The more is the solubility of carbocation, the more will be the stability of carbocation, and the more will be the E1 reaction. So, the polar solvents always favor E1 reactions because they stabilize the intermediate carbocation. As we have discussed, that the stability of carbocation is more important in the E1 reaction, and the polar solvents, they will stabilize the carbocation more as compared to the non-polar solvents. So the more is the stability of carbocation, the more is the E1 reaction. An example is the E1 elimination reactions from alcohol in aqueous or alcohol solution, which are very much important and very common. Look into this reaction. This is an alcohol, and in the polar solvent water, it undergoes the elimination reaction. Same is here. A ketone is converted by the Grignard reagent to an alcohol, and this alcohol then can undergo elimination reaction in the presence of water. This is the mechanism of this reaction, that how it proceeds. The protonation of hydroxyl group, the removal of water, formation of carbocation, and then the removal of the proton and the formation of double bond. The role of leaving group. The stability and the efficiency of leaving group is directly involved in the formation of carbocation. The better is the leaving group, the fast will be the elimination, and the more will be the rate of the E1 reaction. A good leaving group will lead to a fast elimination, and a stabilized tertiary cation could be formed, but no strong base is present, so the mechanism must be E1. Here, it's the removal of an amine. We get a stabilized tertiary cation, and then the formation of a double bond. E1 reactions can be stereoselective. Look into these products. Here, we have the possibility of only one position, one product. The same is the case here. We have the possibility of one product. So there is no question of stereo or regio selectivity. Now look into this molecule. After the formation of carbocation, there is possibility that the other proton may be lost from this methyl group or from this carbon. They are equivalent. So there are two products possible, tri-substituted alkene and the di-substituted alkene. Now look into this molecule. After the formation of carbocation and the removal of this hydroxyl, the carbocation will be found here, and now we have two possibilities. Which one? That here, if you see, an E alkene can be found or a Z alkene. Here, this is a Z, Suzaman, or this is an E alkene. These are two stereoisomers, geometrical isomers with each other. So there is the possibility of these two alkenes. We will study later on that how these are formed. An E1 reaction can be stereoselective. E1 alkenes and transition state leading to E alkenes are usually lower in energy than Z alkenes, and the transition state leading to them be farther apart from one another. When there is choice, the formation of E alkenes, less hindered alkene is favored. Like in the previous slides, we have seen that there is the possibility of formation of E and Z alkene. Now, E alkenes are lower in energy than Z alkenes. Why? In the transition state, the bulky groups are farther apart from one another. So when there is a choice, the formation of E alkene will be favored. Like here, we have 95% E alkene and 5% Z alkene. E1 reaction can be reduced selective. The more is the substituted alkene, that is Z's of rule, the more will be the major product. Here, look into this compound, this alcohol, it's a secondary alcohol. After the formation of carbocation, here it's the possibility that the proton will be lost from this carbon or from this carbon. And so as a result, the double bond formation is possible here or here. Now, if the double bond is found here, it is the more substituted alkene. And here it is less substituted alkene. So more substituted alkenes are more stable and more favored. So this one will, the more substituted product will be the major product. Applications of E1 reactions. Elimination reactions are important as method for the preparation of alkenes. The term elimination describes the fact that a small molecule is lost during the process. A 1,2 elimination or beta elimination indicates that the atoms that are lost come from adjacent carbon atoms. Most of these reactions and these were from the organic chemistry by Claydon, but it's available in these two books also, Buchner and by the Jerry March. Thank you very much for your patience. Thanks.